Hi, and I'm back again after that great STEM panel. So, we are here to talk about the new ICML Varnish badges. They are very, very amazing. I love the fact that, we actually get to get these varnishes. And we have Greg Livingstone here with us, and he's going to explain to us about those ICML Varnish badges. It's something that has been in the making time, and I know he's definitely going to get into detail with that. He was one of the people involved in getting it together. So, brilliant person to learn from. And I'm going to pass you over to Greg now, who's going to tell you all about those ICML Varnish badges.
Hello, I'm Greg Livingstone with Fluitec, and today I will be talking about ICML's new varnish badges. And in addition to talking about the varnish badges, I will also be revealing to you a top 10 list of lesser known facts about varnish. So let's get started. Who is ICML? The International Council for Machinery Lubrication is a vendor-neutral, not-for-profit organization that's been around for 20 years, really designed to help lubrication practitioners. They have become somewhat of an authority on machinery lubrication and have developed certifications that can really help practitioners show that they have attained a certain body of knowledge. And they've really put a lot of work into optimizing asset reliability, utilization, and cost through machinery lubrication. So there's a reasonable chance that you have heard of the International Council for Machinery Lubrication. ICML's Machinery Lubrication Technician, or MLT certification, very popular. There's also machinery lubrication analyst. There's the newest one is a machinery lubrication engineers certification, which is purportedly, I haven't taken the exam yet, but purportedly the hardest certification to achieve in our industry. They have introduced two new badges that are specifically focused on varnish. And so badges may be a little less intensive than full certification. But it does allow you to show in these niche parts of the machinery lubrication space, you've attained a certain amount of expertise on the subject matter. And so in varnish and deposit, for varnish and deposits, there's two badges that they've created. One focused on identification of measurement, so that's referred to as a VIM badge, and another on prevention and removal. That's referred to as the VPR badge. Who should look at getting their varnish badges? Well, pretty much anyone on the end user site. If you're dealing with equipment that is susceptible to varnish, it makes sense for you to learn a little bit more about this to be able to ensure your assets are not victim to some of the detrimental impacts of varnish. So people like reliability engineers, operation and maintenance managers, root cause analysis specialists, vendors also that are providing services to these end users can have a lot of value in getting this certification. So filtration specialists, people that are selling lubrication or lubes or lubrication related services, laboratory technicians, or also people on the research side. Now what I would like to do is introduce a top 10 list. For those of you maybe based here in the US that have been around for a little while, that may remember a late night TV host, David Letterman. He was somewhat famous for introducing top 10 lists. So without the comic relief, I will try to provide a Letterman-esque type top 10 list for the lesser known facts about varnish. And the key thing to keep in mind is if there are any of these things that are a little surprising to you or you're not aware of, well, maybe it makes sense for you to learn a little bit more about varnish, take a preparation class, and look at getting your varnish badge. Okay, here we go.
Ladies and gentlemen, here's tonight's top 10.
Number 10, green is not always good. In our current environment, companies are trying to become more and more sustainable, making their practices greener and greener, but varnish can also be green, and so green is not always good. In this particular case, this is actually from a polyester fluid, and the chemistry of this deposit is a phthalate. That chemistry, that name may not sound familiar, but its smell probably does. Phthalates are a plasticizer, and they're also the chemical that's responsible for providing a new car smell if you get a new car. So new car smell good, green usually good, but green phthalate type deposits not so good. Number 9, low MPC does not mean varnish free. There's, just to preface this, the membrane patch colorimetry test became an ASTM procedure in 2013 and is by far in our industry the best tool that we have to predict the onset of varnish and to allow us to understand from taking an oil sample how prone a system is to varnish. But it does have limits, and it's important to understand these limits. So this is an example from a nitric acid compressor train. The bearing temperatures were high, very, very high, 115 degrees C, and the MPC in the system was 12. So low MPC doesn't always mean varnish free. To go into the details on why this is would take another course, or certainly longer than we have today. Number 8, higher MPC is not necessarily worse. This may be a little bit counterintuitive. Here is an example of an in-service oil that actually is in really rough shape. The MPC was 60, but you can see that we put this in an accelerated oxidation bath and then took this fairly beat up oil and thermally stressed it for another 6 weeks at 120 degrees. You could see the MPC actually went from 60, 66, and then actually dropped down to 56. Anytime you see this kind of splotchy type material or splotchy appearance on a patch, it typically indicates the MPC is kind of maxed out, and now in many cases you'll see the MPC level go up and up and up and hit a maximum and then actually start going down a little bit. Here's another example also from this accelerated oxidation bath. We see an oil at 0, 3, 6, 9, and 12 weeks. The first 9 weeks, everything looks somewhat predictable from an MPC point of view. Look at week 12. The other interesting thing is you can see it becomes a splotchy as well here. And so we actually see it, this oil at week 12 is actually more degraded and has produced more deposits than the oil at week 9, even though the MPC is a little bit lower. So just keep that in mind. There's not always a direct correlation to the higher the MPC, the worse varnish potential the fluid has. Number 7, varnish can be strong enough to move a rotor. Many of us think that varnish is somewhat tenacious and a pretty tough substance. It is, and in fact we've been able to correlate this by looking at varnish-induced temperature excursions on bearings and then being able to match those events to actually a vertical shift in the rotor position. And essentially this micron layer or multi-micron layer of varnish will actually move the entire rotor up that amount as well. So oil being this non-compressible triangle, this wedge that's keeping the rotor away from the bearing, if you increase the level of varnish, you will actually move that rotor up a little bit. Amazing. Number 6, varnish can be turned into bulletproof vests. Well, not exactly. However, there's a really cool reaction that takes place if you have ammonia that may be ingressing into the oil, reacting with degradation products from the oil. So one of the key degradation products due to oxidation are carboxylic acids. These can react with ammonia and create this substance called a primary amide. It's important to understand because this is a high molecular weight material, comes out of the oil very quickly, and this is another case where it may be challenging to actually measure the presence of these deposits through the MPC test because it doesn't stay in the oil that long. The other use for amides is actually in the manufacturing of Kevlar. And Kevlar, of course, we use for bulletproof vests. So in fact, this reaction that we see in the oil is in fact somewhat related to bulletproof vests. Number 5, varnish doesn't necessarily kill all your oil properties. This is a little bit counterintuitive. If you think about varnish and these degradation products as being polar, you would think that it would have an impact on things like, say, foam or the oil's ability to separate from water, the demulsibility test. In fact, we don't necessarily see that. And this is an example here where we have 350 samples of a wide range of different MPC values and a wide range of different demulsibility characteristics. And then we correlated these. What is a correlation between this? If you had a perfect correlation, it would be 1. And if you had if it was indirectly correlated, you would have a correlation of -1. Our correlation here is 0.06, which essentially means there is no correlation. The higher the MPC, it doesn't necessarily mean even the introduction of these polar constituents will negatively impact properties like demulsibility. These are more often deteriorated by the presence of contaminants. Number 4, there is more to solubility than polarity. Most people will know that oil and water don't mix, and the reason is that oil is nonpolar and water is polar. So polarity has a tremendous amount to do with solubility. However, if you just focus on polarity, and in our oil world we would think of this as maybe the aniline point, if you just think about polarity, you're actually missing a couple other factors here that are at play. So certainly polarity is one factor. Another factor that we see is also hydrogen bonding, and a third actually is dispersive forces. So if you understand all 3 of these forces, you can create a 3D model and really understand the characteristics of the varnish or the degradation products, the characteristics of the fluid, and you can understand where and when and how this varnish will come out of solution. Number 3, sparks create cool deposits. So many people don't realize if you have electrostatic spark discharge events happening, often we see these in filters, especially filters in cooler spots of the system. If you see or if you have deposits that are generated because of these spark events, they create a thermoplastic type material. And if you look at the picture here to the right, it looks like actually a broken chunk of coal. And but the interesting thing is if you put all of these chunks together, melt it down, and it'll recongeal and look like this sludgy component here to the left. So it really actually acts as a thermoplastic, and it's a pretty cool material. Number 2, formulation plays a significant role in varnish. This is also a little bit counterintuitive to some. We know that, say, in the world of turbine oils, the vast majority of turbine oils are base oil with a small amount of antioxidant. So one would maybe suspect that there would be some similarities between their performance, but in fact there's not. There's a pretty significant difference in how these different oils are formulated. So here's an example of one type of Group 2 turbine oil. You could see the life of the oil over this 6-week accelerated oxidation test. The antioxidants have depleted, the RPVOT has dropped, and we also see an increase here in the MPC test, as well as actually deposits here in the glassware. We can compare that to another Group 2 oil. In this particular case, the life of the oil is a little bit improved. The RPVOT and aminic antioxidants will last a little bit longer. In this particular case, we actually didn't really see any development of a stain on the patch, and no stains whatsoever in the glassware. So this particular formulation, fantastic deposit control properties. And then we go to next gen oil. This is a Group 3 turbine oil. Actually, in this particular case, the antioxidants and RPVOT retention It was very, very good. So this we would expect to have a very long oil life. However, there was a little bit of a stain here. This is an MPC of about 36, so a little bit of a stain on the patch. However, the amount of actual stain on the glassware is pretty equivalent to the first example that we looked at here with the an older generation Group 2 oil. So not necessarily a correlation even between the MPC stain and the stain that we see in the glassware. Also, Group 3s, not necessarily better than Group 2s. It really comes down to how the oil is formulated and how these antioxidants are all balanced together. And here we get to the number one thing about varnish. There's still a lot we don't know. So, for example, we may have a combined cycle power plant. 2 exact models of turbines at the same plant, commissioned at the same time, the same oil, identical duty cycle, for, say until their first outage for 48,000 hours. One system has varnish, the other doesn't. Why is that? There's many theories and hypotheses about this. We don't exactly know the details on this yet. Varnish chemistry. Another key thing that we're still understanding and trying to better figure out. Why does varnish, the same types of varnish form both in really cool parts of the system where the oil, where these degradation products are precipitating out, coming out of solution, and also are forming in the hottest parts of the system, even though they're similar varnish. Finally, varnish testing. MPC is super effective, especially at early detection of varnish. However, once you get to a certain level, it's really hard to differentiate, and especially in, say, non-turbine applications in the world of hydraulics and other applications where you would have a tremendous amount of thermal stress in the fluid, we still need to look at other tests in addition to the MPC test. So to summarize, the International Council for Machinery Lubrication varnish badges are a great way of showing that you have developed some subject matter expertise in the world of varnish. If there were any of the top 10 lists that I presented that were new items to you that you were not familiar with, another good reason maybe to look at taking a preparation class and look at getting your varnish badges. And I hope to see your name up here with mine, with your VPR and VIM badges here in the near future. Thank you very much for your time. Tremendous privilege again to be able to present at LRVS.
Thank you so much, Greg. Like, I learned a lot from that presentation. I have all my notes written down. There are a lot of the top 10 things that just blew my mind. You know, of course, blew my mind, as they usually do. So I wanted to talk a little bit more about the ICML badges. How do we go about getting those? Because I know right now, I think there are only about 10 people with them globally, and you are one of those, of course.
So the ICML certification badges, they're kind of micro certifications. So they're showing you have some expertise in a specific niche of the market, and but typically for getting an ICML certification, it's recommended that you take a certification class. Yes. We have just launched a certification class specifically for this. So if you are interested, I think maybe Josh can put a link up in chat, but there's we'll direct you to a website, give you a discount. I think he's also offering a discount, and you can take a certificate or a pre-certification class on this here as well.
Yeah, and you all have the fluid learning booths where they can actually go in and interact with you, interact with Josh. And I know that Josh told me that there's a 30% discount for all attendees. So definitely get that Varnish badge now. I mean, 30%. I love a good sale. So once I see a sale, that's it, you know, discounts. And they are officially ICML training partners as well. So well done. Very proud of you all for doing that. We had one quick, yes, I think Ludger, definitely. Greg is Professor Varnish at this point. You know, Totally agree with you there. Totally agree
Oh,
with you
thank you.
there. And Rich actually made a comment about your three-factor impacts on oil properties. A lot of people don't understand this. So he said it was very well done. And if anybody can put that together, it's Greg, you know. Greg is the professor of Varnish, officially dubbed by Ludger. Thank you for that, Ludger.
Right, I appreciate that, Rich. Just to clarify, I just happen to hang out with some really smart people that some of their knowledge drips onto me, of which I'm very grateful for. But one of our researchers, Christian Soto, has really fine-tuned these solubility parameters and has taken the Henson solubility parameters that has been used for a long time in other industries and applied it here to our space. And as far as we're aware, this is the first time it's been done, but it's really helped us understand, different varnish chemistries, where they're going to form, why, and then also what solutions we have. If you heat the oil up, is that going to dissolve the varnish? If you add a solubility enhancer, is that going to dissolve the varnish? Understanding the aniline point or just the polarity is just it's just one factor in this. So appreciate that, Rich.
Yeah, and I'm just, letting people know the discount code. So write down that discount code. So far, you all can get that discount on the ICML varnish badges. Josh provided us with that. And you can also go to the Fluid Learning booth and get onto the website. I believe the website is in the booth as well. And I know Ravi is very excited. He's waiting for the recording to come out because, yes, you did an amazing job with that top 10 list. There are a lot of things in there that we don't talk about. We don't talk about the green and varnish. We don't talk about all of the different things with varnish that it just never comes out. But putting it together like that in a very succinct, very easy way to understand, you did a great job on that, Greg. Totally great job on
Appreciate
that.
that. One of the fun things about diving into the world of oil degradation is that in the last point, there's still a whole lot that we don't know, and it's kind of fun because you're always discovering new things, and there are hundreds of different varnish chemistries out there, all that behave a little bit differently, and so having a good idea of how the oil is degrading, what methods you can use to detect this, and then what mitigation technologies. I think it's always an evolving space and fun to be involved in.
It is, and Ludger mentioned it, sometimes we see the low MPC values and we're like, okay, well, you still have varnish. How do you explain that to our customer? And I know in the customer's mind, MPC is king. Whatever MPC says, they go with that. How do you help explain that to them?
That's a very good point. So there are some really easy ways, some easy examples. Say if you have a really heavily varnished system, you drain all the old oil, you put brand new oil in, you're still going to have varnish throughout your whole system, even though your MPC is low. So those are some really easy things to comprehend. The more challenging ones are that your whole system's nice and clean. You put a new charge of oil in, and now you're starting to generate high bearing temperatures, just say on one of your bearings, and you have a very localized deposit, and the amount of degradation that's happening is not sufficient to have any kind of impact on the bulk oil, and so the MPC is not going up. But we are working on some new technologies to be able to better predict this and to also better detect this. So stay tuned. This is another area I think that we're putting a fair bit of focus in, because I think Dr. Quick's comments is exactly right. This is the MPC, when it was first kind of introduced, 2005 timeframe, it was first kind of commercialized. 2013, the ASTM standard came out. It has been invaluable for us to better understand and better predict this. Before, we had nothing, but there are limitations, and so the next round of kind of iterations on this is what can we do to detect really early signs of varnish or localized deposits in specific parts of the system. So
Now that sounds very interesting, Greg, and I know you all are leading the change on that one to try and develop and make sure that, like you said, everything has to evolve. MPC when it came out, it was great, but we have moved so far ahead in technology that we need to bring our lab tests up to that speed now, right?
yes, yeah, and that's the thing. There's limitations with that oil analysis sample. I think that there are some techniques that we're looking at that it will give us maybe even earlier signs of oil degradation than the MPC test. However, we're still limited when we draw a sample of oil because if we have a localized deposit happening in one part of the system, trying to get that into the bulk oil that we're able to then collect that tiny little piece of evidence that there could be something going on in another part of the system is challenging. So, but if we are able to combine oil analysis tests with system operational, some operational systems, I think actually Vanda just posted here.
Yes, the Queen of
Bearing
Varnish.
temperatures is one of the systems or one of the symptoms. So that's exactly right. And maybe if we can look at a combination of various operational conditions combined with oil analysis, then even before you start to see this fingerprint of sawtooth type bearing temperature excursions, we may be able to predict what bearings are going to be more susceptible to varnish and when we're going to start to see varnish problems even before they're detected in your with the sawtooth type pattern.
Yeah, and I think that's one of the things that we've heard a lot throughout the conference. Don't just take the test for granted. Look at your system, look at what's going on, your operations. So thank you to Queen of Varnish for jumping in there and helping us with that one and letting us know it's not just tests, it's also your operations and also your systems.
Yes.
And we have Angus just jumping in here and letting us know the website to get your ICML certification exams, for more information on the VPR and whatnot, because they have posted the actual body of knowledge, domain of knowledge for both of the different courses. And like, I am amazed with that course so far. So like, it's going to be very, very interesting. And I am looking forward to that one. We have a comment by Andy, and I think Vanda actually answered his comments. Suppose there are so many variables in systems. That's always one to look at.
And he is absolutely right. And it does make our job more complex. But because there's so many variables, there's also a lot of information that the system's giving us. And there's a lot of information that we're able to extract from the oil. So if you're able to read all of this information correctly, then there's I think potential for a tremendous amount of further insight into the the operation of these systems.
Oh yeah, definitely. And like, to me, when you have to look at your system. You can't just say, okay, well, I saw this report, the MPC is low, our PVOT looks kind of shaky, but you know what? I believe in it 100%. But then your technicians and your maintenance guys are telling you, we're seeing bearing temperatures increasing. We're seeing these things happening. So always work together with your team. And I think it goes straight back to Ryan Chan's keynotes, making sure we don't operate in silos. Operations, maintenance, reliability, we have to work together to get everything done.
Well done, wrapping it all together. Yeah, I could not agree more.
Yep, definitely. And Rich says, he's excited for the other ICML badges to come forward. I know Paul said he's working on some during the pre-conference, some specialized ones. So, Rich, definitely keep in contact with Paul about that. I think
Rich is on the ICML board and also has some insider insight into what's happening within ICML. But this whole concept of these like micro certification badges is just awesome. I think it's a phenomenal idea. And so I think it will be really exciting to see some of the other badges that ICML is going to be coming out with.
I wonder if Rich could provide us with some insight there. But Rich, totally up to you if you want, if you can. I know the trade secrets, ICML, until they launch their badge, then we can hear about it. But we are excited about it. And just wrapping up today, Greg, thank you so much for your time. We're always happy to have you and be able to chat with you, especially about Varnish, just to be able to chat with you. And if you have any questions about the ICML Varnish badges, check out the Fluid Learning booth. Check out Greg. He'll be in and out of that booth. And check out their website for that discount because, discounts are important. So we will stay tuned. We have about 2 more panels, 2 more sessions remaining. And then we'll come to the end of our LRVS 2021. So we'll see you soon. Thank you for joining. Bye.
Thanks, everyone. Bye.